So since we've defined a hyperbolic sine, and I'll write that again for us, e to the x minus e to the negative x divided by 2. We've also got a hyperbolic cosine, which is the same thing but with a plus. It might make sense to define tangent and cotangent and all those other similar things. So we'll go ahead and do that as well. So sine and cosine, we'll have tangent, hyperbolic tangent, so we'll stick the h there. And we'll define that exactly the way you would expect. Sine of x, but not sine, hyperbolic sine, divided by hyperbolic cosine. And what would that end up being? Well, you're dividing this top fraction by this bottom fraction, so the 2's would cancel. And you'll end up with e to the x minus e to the negative x from the sine on top over e to the x plus e to the negative x from the cosine hyperbolic on bottom. And of course the cotangent version, exactly the same, just flipped. So we'll have the plus on the top and the minus on the bottom. And likewise, we can do secant hyperbolic. And that's just going to be 1 divided by cosine hyperbolic. And of course, since we're just dividing by a fraction, we can just flip the fraction. That's going to be 2 divided by e to the x plus e to the negative x. And cosecant, the hyperbolic version, will be 1 divided by hyperbolic sine. And that'll be the same, but with a minus. So, we've got these new definitions. We should make sure we know how to evaluate things that involve them. So as an example, let's evaluate the hyperbolic secant of the negative natural log of 2. Okay, so what happens if we do that? Well, I've got this nice formula. It's right here at the top now. So I will just do what I always do when I'm evaluating hyperbolic functions. I'll just take the function and rewrite it in terms of exponentials. And the formula says, since I don't know what the cosine hyperbolic of natural log of 2 is offhand, I'll just rewrite everything in terms of e to the x as it is in this formula up above. So I have e to the negative natural log of 2 plus e to the negative natural log of 2. And then it's just evaluating exponentials and logarithms. I've got 2 over, that negative in the exponent means it's a fraction, 1 over, then the e and the natural log will cancel. So 1 over 2 plus, and then again the e and the natural log cancel. I've just got a positive 2. So that gives me 2 divided by 5 halves. 1 half plus 4 halves is 5 halves. And then I can bring that 2 in the bottom up to the top. I've got 4/5 for the value of hyperbolic secant at this particular value. Okay, we also have similar properties. We have something similar to the Pythagorean identity involving tangent and secant, but this time it's hyperbolic tangent, hyperbolic secant. I'm going to prove this identity, that hyperbolic tangent squared equals 1 minus secant, or the hyperbolic secant, squared. All right, so how's this going to go down? Well, again, I'm just going to write out both sides of the equation. I'll start with the left-hand side. Hyperbolic tangent squared of x is the square of the hyperbolic tangent. And so I have my formula up here. So I'll take my formula right here and rewrite it down here. And it's a negative on the top because it's sine over cosine. We'll do it again on the bottom. Positive. Now, I can square the top and I can square the bottom. Using a bit of algebra, I'll get the first term squared, e to the x squared, minus 2 e to the x, e to the negative x, plus e to the negative x, all squared. And I'll divide that by, well, the bottom is exactly the same, e to the x squared, but since I have this positive here, it's going to be plus 2 e to the x, e to the negative x, plus e to the negative x squared. Now, I want to simplify this. Well, e to the x times e to the negative x, that's just e to the x divided by itself. So I'll scratch those out on both the top and the bottom. And then maybe simplify. I've got e to the 2x minus 2 plus e to the negative 2x on the top. And I get exactly the same thing on the bottom, e to the 2x, except I have a plus 2 plus e to the negative 2x. Now it's possible I could manipulate that some more, but I think I've simplified it, I've expanded it out enough. Let's see what happens if I take the other side of the equation. Hopefully I'll get the same result. So coming back up here, I've got 1 minus secant squared, or of course 1 minus hyperbolic secant. So I'll write out the formula. So that's 1 minus, so I'll put 2 over e to the x plus e to the negative x. That's the formula that we introduced earlier. It's just the cosine hyperbolic flipped. And then I'll expand that out. I'll, of course, square the top. That's easy. And we squared the bottom just a moment ago. I've got 1 minus 4 on top divided by, on the bottom, that's e to the 2x plus 2 plus e to the negative 2x. And you can check my work on that. It's the same thing as that guy right there, actually. So that's not quite the same as what I was looking for, but if I get a common denominator, maybe that'll fix it. And in fact, it does. When I get a common denominator, I'll get e to the 2x plus 2 plus e to the negative 2x. And then notice I have a minus here, so it'll be minus 4 all over the common denominator, e to the 2x plus 2 plus e to the negative 2x. And then finally, I can cancel, well not cancel, I can take the plus 2 minus 4, that's just negative 2. And that gets me e to the 2x minus 2 plus e to the negative 2x all over e to the 2x plus 2 plus e to the negative 2x. And sure enough, that's exactly the same thing as what I got before. So they are equal, and that finishes the proof.